Well, welcome back to GIS Analysis at the University of Alaska Fairbanks. This week we're going to work with LiDAR, and LiDAR stands for Light Detection and Ranging, or laser altimetry. And it's basically using laser pulses to estimate heights. So we have a plane flying, and we have laser pulses, and the last return is going to be near the ground surface. And the first return is going to be near the top of the canopy. So what we'll do in ArcMap is we'll start by simulating rasters representing the last return and rasters representing the first return. So the first thing I'll do is set my default geodatabase to a test geodatabase. So File, Map Document Properties, and then I'll set my default geodatabase to NRM 435 test LiDAR. And then we'll use a geoprocessing tool to make a random raster representing near the ground surface. So if we search for random, there's two create random rasters. And what we want to do is use the create random raster in the data management toolbox. So I name my output raster last return raster. And what we'll do is we'll create a normal or bell-shaped distribution, so normal, with an average value of an elevation of 100 meters. And let's give it a standard deviation of 0.1. So then we'll randomly have a raster ranging. The mean will be 100 meters, and it'll have some random variations with a standard deviation of 0.1. And the name of my output raster is last return. And then just OK to execute the tool. So that creates our raster representing the ground surface. So let's say this is near a floodplain where the elevation of the floodplain is about 100 meters. And there's some random variation in the ground surface. So next what we'll do is create a raster representing the first return, or top near the top of the canopies. So next we'll create a raster representing the first return, which would be near the top of the canopies. And let's say that's going to represent the elevation near the ground surface all the way up to the top of a spruce tree, which is 30 meters high. So we can use the same tool, create random raster, and this time we'll name this first return. And we'll give it uniform random numbers ranging from near the ground surface, which is 100 meters, to, let's say, the tallest spruce tree is 30 meters high. So if we take the ground surface plus 30 meters, would give us 130 meters. So here are our simulated LiDAR rasters. Each grid cell is 1 meter wide, 1 meter high. And this is near the ground surface, and this is near the top of the canopy. So we can use the identify tool to look at any 1 meter pixel. So for example, this pixel 99.93 was the ground elevation, and 114.67 was the first return representing the canopy. So that might represent, for example, a tall shrub, as opposed to this pixel 125 meters and 100 meters, that may represent the top of a 25-meter tree. So in the next video session, we'll calculate a raster representing the top of the canopy, and then we'll isolate all the tall pixels that are above some threshold height.